Hello, everybody. Welcome to the second part of limits in calculus. I'll be using Thomas's calculus book, and if you would like to download your own copy of the book, which I would highly recommend, please search for Thomas's calculus book with the word download, and you'll find many websites to download it. This is one place you could download it. So we'll go to chapter 2, and if you have not seen limits, the first video of the limits, stop right now and go and watch that video and come back to this video. So this is chapter 2, limits and continuity. Let's look at one example. So in this example, we have this graph, and we'll take points 0, 1, 2, 3, and 4 and see if the limits exist and what the value of the limit is. So first we'll look at x equals 0. At x equals 0, if you look at the limit from the positive side, this way, come in this way, so we'll write it down. Limit x tends to 0 from the positive side, what the value of the function is. If this is fx, value of the function would be, you see that it's tending to 1. And if you look at the limit from the negative side, x from the negative side, you see that is not defined because we know nothing about the negative side. So it's not defined. So because they are not equal, so the limit does not exist. So let's look at 1. At 1, so this at 1 from the positive side, you see that from the positive side, we'll look for limit. Maybe I'll change the color of it. And let's take a different color. So limit as x tends to 1 from the positive side. From the positive side, we see that it tends to, fx tends to 1. From the negative side, we see that limit as x tends to 1 from the negative side, fx is equal to 0. And these two are not equal to 0, so it does not exist. Limit does not exist. Let's look at 2. So 2 from the positive side, this is the positive side. Let's change the color again to red. From the positive side, limit is equal to 1. So let's look limit as x tends to 2 from the positive side, fx is equal to 1. And from the negative side, you see that fx is equal to limit as x tends to 2 from the negative side, fx is also equal to 1. So the limit exists and the limit is equal to 1. And the value at 2 is 2, but that doesn't affect the limit. Limit is just before 2. What happens to it just before 2? From the left side and the right side, it shows that it tends to 1, so the limit is 1. Let's look at 3. So I'll change the color again. So limit as x tends to 3 from the positive side, we see it tends to 2 is equal to 2, and from the negative side also it tends to 2. So limit as x tends to from the negative side is also equal to 2. So since they are equal, we say the limit as x tends to 3 is equal to 2 of fx is equal to 2. Let's look at the fourth example. At 4, we see for limit as x tends to 4 from the positive side is not defined. It does not exist. And limit of fx, I should say, x tends to 4 from the negative side, we see fx is equal to 1. So this is not, the limit at 4 does not exist because one side is not defined. Let's go to the next problem. The next problem is taken from exercise 2.4 from the textbook Thomas's Calculus. So what we are expected to do is find the limits graphically of y equals fx. So that's what we are supposed to do. So let's look at the limit of x. See whether these are true or false. So we'll look at x tending to -1 from the positive side. So -1 is here from the positive side. Coming to is from the positive side is equal to 1. This is true because from the positive side, from the negative side, it's not defined. But from the positive side, it tends to 1, so this is true. So here, if you look at x tending to 0 from the negative side, and that is 0. It tends to negative. It approaches 0 from the negative side. So that is true again. Limit x tends to 0 from the negative side, fx is equal to 1. That's false because we said it was true here. From the negative side again, right? 0 negative side, it tends to 0. So this is false. Then let's look at this. X tends to 0 from the negative side, which tends to 0, is equal to x tending from the positive side to 0. So we see that x, if I clear these things, we see that x tending from the positive side to 0 and negative side to 0, it goes to same place. So this is true. So the limit exists and the limit is equal to 0. I am aware that f of 0 is equal to 1, but limit of x tends to 0 of fx is equal to 0 because from the positive side and the negative side, the limit tends to 0. So let's look at E. So x tends to 0, fx exists. This is true. And we proved that limit of fx is equal to 0. Then let's see limit of x tends to 0 exists, and this is also true. We proved that a limit of x tends to 0 of fx is equal to 0. Let's look at this limit of x as x tends to 0, fx is equal to 1. It's not correct. It is equal to 0. Then h limit as x tends to 1 of fx. So let's look at limit of fx tends to 1. So as x tends to 1 from the positive side, we see the limit is 1. From the negative side, limit is 0. From the negative side, limit is 1. So limit, let me write that for clarity. We'll take that part. So limit as x tends to 1 from the positive side, if it tends from the positive side, fx is equal to 0. From the positive side is 0. Limit of x tends to 1 from the negative side of fx is equal to 1. These two are not equal, so this is false. Then I, as x tends to 1, as x tends to 1 is the limit of fx equal to 0. That is not correct because it is not defined. The limits from the left and the right are not equal, so it is not defined. So it is false. limit of x as x tends to 2 from the negative side. Let's look at that next. So if you look at x tends to 2 from the negative side, x tending to 2 from the negative side, that's the negative sign here, not before 2, after 2, negative sign, it tends to 0. So this is false. So x going to -1 from the negative sign does not exist. That is true because x is here in the negative side. Going from the negative side does not exist. If you're coming from the negative side, we don't know anything about this area. We know the value at x equals -1, but we don't know anything about just before -1. So that does not exist is true. X tends to 2 from the positive side. X tends from the 2 from the positive side is equal to 0. That's correct. X to the positive side, it's equal to 0. So that is true. So let's go to the next question. So this exercise was taken from Thomas's calculus, exercise 2.2. Let's look at A. So if this is gx, what happens at x equal to 1? So let's look at x equal 1. This is the position. X equal 1, as limit approaches, let's say limit as x tends to 1 from the positive side of gx, we see that it tends to 0. And limit of x tending to 1 from the negative side, gx, we see it is equal to 1. So they are not equal, so it does not exist. Okay, so let's look at limit equal 2, tending to 2. So if you look at from the positive side, it goes to 1, right? This is 1. From the negative side, also 1. So let me write that down. Let's say b limit x tends to 2 from the positive side, gx, we get 1, and limit x tends to 2 from the negative side, we get gx as equal to 1. So as these two are equal, it does exist and the value is equal to 1. Let's look at 3. At 3, from the positive side, it tends to 0. From the negative side, it tends to 0. So it exists and the limit is equal to 0. It exists and it limits is equal to 0. Though g of 3 is equal to 1. G of 3 is equal to 1. But that doesn't matter. Limit is all about just before 3, what happens? Just after 3, what happens? So let's look at 2.5. 2.5 is somewhere here. I'll change the color of my pen. So 2.5 is somewhere here. What happens at 2.5? So limit as x tends to 2.5 from the positive side, gx, it is around half, and limit as x tends to 2.5 from the negative side, gx is also equal to half. So limit exists and the limit is half. Let's look at another problem. This is also very interesting problem. So this function is fx is defined for when x is less than 2 and when x is greater than 2. So when x is less than 2, the function is represented by y equals 3 minus x, and when x is greater than 2, the function here drawn here is the x over 2 plus 1. So let's answer question 1 in A in green. So we see that when x is tending to 2 in the positive direction, we see the value is, if this 1, 2, its value is 2. When x is tending to 2 in the positive direction, the value is 2. But when the limit of x as x tends from the negative direction, the value is 1. So the limit from the positive direction is not equal to the limit of negative direction. So the limit does not exist. Limit does not exist. So let's answer the second question in light blue. Does the limit as x tends to do exist? No, it does not exist. Because why is it? Because the left hand limit is not equal to the right hand limit. So it does not exist. Then let's find the limit at 4. So limit at 4. Look at the limit at 4. From when the limit from the right hand side is equal to from right hand side or from the negative side, it's equal to 3, and from the positive side is equal to 3. So let me write that limit as x tends to 4 from the negative side, fx is equal to 3, and limit x tends to 4 from the positive side, fx is also equal to 3. So does this exist? Because they are equal, yes, the limit exists at x equals 4 and it is 3. It is 3. The limit is 3. Let's look at the next question. This question is very similar to the previous question. We want to see the limit at as x tends to 2 from the positive direction and as x tends to 2 from the negative direction. So this is 2. From the positive direction, we see it tends to 1, and from the negative direction, we see that it tends to 1. So limit as x tends to 2 from the negative direction of fx is equal to 1, and this is also equal to limit as x tends to 2 in the positive direction fx. So as these are equal, the limit exists. Let's look at minus 1. So this is minus 1, and I'll use a different color for that. So minus 1, and we see that as x tends from to minus 1 from the negative side and positive side, you see something like you see it's 4. It tends to 4. So limit as x tends to minus 1 from the positive side, fx, or let's start with the negative side, fx is equal to 4 and is equal to limit as x tends to minus 1 from the positive side, fx. So again, limit exists. Let's move on to another problem. This question is very interesting. Its first question it says is graph fx. Fx as x is equal to x to the power, fx is equal to x to the power 3 at all places where x is not equal to 1 and is equal to 0 when x is equal to 1. So to graph this, let's first look at fx equals x. So the graph of fx equals x is, as you have seen me graph this, it is this. Then let's do fx equals x squared. So fx equals x squared is x and y, and this is f squared. So what happens, how do you use this information to draw fx equals x cubed? So if you look at x cubed, when it's positive, it's always positive. When x is positive, it's always positive. But when x is negative, though in x squared, when x is negative, it's always positive. For example, when x is equal to minus 1, x squared is equal to positive 1. X is equal to minus 2. X squared is equal to 4. So it's always positive, and that's why we get a curve like this. But in x cubed, When x is equal to minus 1, x cubed is equal to minus 1, not plus 1. When x is equal to minus 2, x cubed is equal to minus 8. 2 times 2 times 2. So it's 8. So this part of x squared changes. So the x cubed function would be something like this. Okay. So they want you to draw x cubed everywhere when x is not equal to 0, when x is not equal to 1. So let's do this. This is 1 x-axis and this is y-axis. So at 1 the value is 0. So at let's try to draw this. This is your x cubed, except at 1. At 1 there is no value. At 1 they say the value is 0, not x3. It's 0. So that is because of this clause. It says the value function of fx is equal to 0 at x equals 1. 0 at x equals 1. Everywhere else it is equal to x to the power 3. It's something like that. So then they ask you to find the limit as x tends to 1 from the negative side. Let me use some other color for that. From the negative side. As x tends to 1 from the negative side, we know this is 1 here. It tends to 1. Find limit x tends to 1 from the negative side is fx is equal to 1. And from the positive side, limit of x tends to 1 from the positive side of fx is also equal to 1. Does the limit exist? Yes. Limit exists? Yes. This is C. It is yes. And the limit is equal to 1. So limit is as x tends to 1, fx is equal to 1 because limit as x tends to 1 from the negative side, fx is equal to limit of x tends to 1 from the positive side. So there you go. Let's do the next question right away. So in this problem, you're asked to find the limit as x tends to infinity. When you encounter a problem like this is one thing you need to remember. Think of, for example, what is the curve of y equals x? Y equals x, the curve is x, y. And that's the curve of y equals x. And if you look at the curve of y equals x squared, you will see that at 0, sorry, we don't need to get y equals x squared. Before that, let's do 1 over x. 1 over x. So at 0, 1 over x is x as x tends to 0. It's not defined. So 1 over x would be a curve of this nature. And then y equal to 1 over x squared would be a similar curve. Y, the only difference is the curvature. It gets to 0 as x tends to infinity, as a 0 faster, and even curves of any nature of 1 over x the power half, 1 over 3, all these, the whole family of curves follow the same trend. That is, as x goes to infinity, the graph tends to 0. Whether it's negative in infinity or positive infinity, the graph tends to 0. So this is x and y. So this is something you need to remember when you're solving, finding the limit. So if we can convert this equation to a 1 over equation, 1 over x squared, 1 over x cubed, or 1 over x to the power half, we know the answer of what happens to functions that are 1 over when there's a variable in the denominator. We know that as x tends to infinity, the function goes to 0. So let's look at this function, and we will divide this by the highest power of x. And here the highest power of x is x by itself. So we divide the whole function by x. So we take limit as x tends to infinity, we take 2 square root of x over x, because we're dividing the numerator and the denominator by x. And here this is 1 over x. So when you divide it by another x, we get x squared. And we have 3 minus 3 over x. Now we see we have a lot of functions with x in the denominator. Of course, this can be rewritten as limit x tends to infinity as x over, 2 as 2 over square root of x, because square root of x over x is equal to 1 over square root of x. I'll show you why this is. This is because this can be written as square root of x times square root of x. So you can cancel off one of these, so we get 1 over square root of x. So we have plus 1 over x squared over 3 minus 7 over x. So when you look at this, this is a proper form because we know all functions where the denominator is a form of x, this if x power a, where a could be 1, 2 or even fractions, as x tends to infinity, the function goes to 1 over x to the power a goes to 0. We know that for sure. So now we see this tends to 0, this tends to 0, and this tends to 0. This remains 3 and this tends to 0 as well. So the answer would be 0 here. So limit, the answer would be 0. We'll look at the next question quickly. The next example is, as x goes to minus infinity, square root square root of 3, x square root of 3, square root of 5. Let's look at the square root of x first. Square root of x is also equal to, this is what this symbol means, square root of x, right? So, and this symbol, it means 3 means x to the power 1/3, and square root of x is 5 is equal to x to the power 1/5. Let's see whether 1/3 is greater or equal or greater than 1/5 or vice versa. So let's take a circle. We see this is 1/3 and 1/5 would be you see it's clearly smaller. So 1/5 is clearly smaller. So we see that 1/3 is greater than 1/5. So if 1/3 is greater than 1/5, as x tends to infinity, we know that we are divided by the highest power of x. So the highest power of x would be 1/3 here. So let's do the limit. Let's write limit as x tends to minus infinity, x to the power 1, I'm rewriting this to the power minus x to the power 1/5 over x to the power 1/3 plus x to the power 1/5. So we'll divide it by the highest power. So this is, as 1/3 is the highest power, we'll do limit as x tends to minus infinity. We have x to the power 1/3 over x to the power 1/3 minus x to the power 1/5 over x to the power 1/3, as we are dividing the numerator and the denominator by x to the power 3. So x to the power 1/3 divided by x to the power 1/3 plus x to the power 1/5 divided by x to the power 1/3. So these cross off, and when you cross it off, remember you get 1 here, not 0, we get 1 here. It crosses off to 1. This crosses off to 1 as well. So we have limit as x tends to minus infinity, we have 1 minus x to the power. So this can be written as x to the power 1/5 over x to the power 1/3 is equal to x to the power 1/5 minus x to the power 1/3. So we can subtract, because they are divided, we can subtract these fractions. So we'll write that right away. 1/5 minus 1/3 over 1 plus x to the power 1/5 minus 1/3. Because this is in the denominator, we use it as minus 1/3. Okay, we subtract the fraction. So let's do the subtraction. We use the common denominator, which is 15, and 3 minus 5 here. So it is x to the power minus 2 over 15. So this means 1 over x to the power 2 over 15. Now this is a convenient form because we know any function of this nature to the power a could be any value, as x tends to infinity, 1 over x to the power a, where a can be any fraction or an integer, tends to 0. So this is very convenient. So let's write this. Let me divide this like this. So we get limit as x tends to minus infinity. We have 1 minus x to the power 1 over x to the power. Let me rewrite that. I don't think I wrote it correctly here very clearly. So minus 1 over x to the power 2 over 5 over 1 minus plus here 1 over x to the power 2 over 15. Sorry, not 5, this is 15. Right? So when you do that, we know as x tends to 0, infinity plus or minus infinity, this goes to 0. So we are left with 1. 1 over 1 is 1. Okay? Let's do the next something very similar again. So I'm going to conclude this video with these 4 questions, and I would like you to pause the video and look at these questions and try to answer it by yourself, and then come and watch the video to see whether you did it correctly. So please pause, complete this, and come back. So the answer for 13, let's do question number 13. Fx is equal to 2x plus 3 over 5x plus 7. So what do we do as x, the limit? We need to find the limit as x tends to infinity. They ask you to find the limit as x tends to positive or negative infinity. So what we do here is we divide it by the highest power of x, right? I'll get rid of this. So we use the highest power of divided by the highest power of x, which is x. So we get limit as x tends to plus or minus infinity, 2 plus 3 over x, 5 plus 7 over x. And these you can say as x goes to infinity. We know 1 over x goes to 0. So these go to 0, whether it's positive infinity or negative infinity. So we get an answer of 2 over 5 as x goes to positive infinity or negative infinity. So we'll do question number 14. Fx equals 2x to the power cube by 7 over x to the power 3 minus x squared plus x plus 7. The highest denominator, highest power of x is in the denominator, x to the power 3. So we take the limit as x tends to plus or minus infinity. We divide it by x to the power 3. Then we have 2 plus 7 over x to the power 3 over 1 minus 1 over x plus 1 over x squared plus 7 over x cubed. As x tends to infinity, all these values tend to 0. So we only have a value 2. So the limit as x goes to positive or negative infinity, it's 2. So question number 15, this is question number 13. Question number 15. 15, we subtract, so we divide fx, the question is fx, x plus 1, x squared plus 3. We divide the numerator and the denominator by x squared. Then you get 1 over x plus 1 over x squared over 1 plus 3 over x squared. So as x goes to infinity, all these values go to 0. As x tends to the infinity, this goes to 0 and this goes to 0. So does this goes to 0. So we have an answer of 0 here. So if we look at question 16, it is question 16. It's 3x plus 7 over x squared minus 2. We divide the equation by x squared, so we get 3 over x plus 7 over x squared over 1 minus 2 over x squared. So we know from the past, from the graphs, we have seen graphically as x tends to infinity, 1 over x tends to 0. So 3 over x tends to 0. As x tends to infinity, 1 over x squared tends to 0. So 7 over x squared tends to 0. This term tends to 0 as well. So we have an answer of 0. So I would encourage you to go through the other parts of the exercises in chapter 2 under limits. And if you find any question hard, or if you can't do any questions, please leave a comment under this video and I will strive to answer those questions. Okay, take care. Bye.